All right, so in this video, we're going to be looking at finding the parametric equation and the symmetric equation for the line of intersection of two planes. So let's start with our plane. So one plane is going to be 3x minus 2y plus z equals 1. And our second plane is going to be 2x plus y minus 3z is equal to 3. Now, to find the equation of intersection of the planes, essentially what we're going to do is first try to reduce our relationship. We want the variables x, y, and z to all be on the same line. So what we're going to do is we're going to take one of our equations, solve it for one of our variables, and then substitute it into the other equation, which will reduce our equation to 2 variables from 3. And then we'll use a parameter for one of those variables, and then we'll get our equation from those relationships. Now, it does not really matter which variable you're substituting. So I recommend picking a variable that has the least amount of coefficients on it. So like a coefficient of 1. So the z in this first equation or the y in the second equation would both be appropriate because they'll give you whole numbers. They'll make things as simple as they possibly can be. So just for linearity's sake, I'm going to solve for z in the first equation. And so that's going to give me z is equal to 1 minus 3x plus 2y. And then I'm going to substitute that into my second equation. So 2x plus y minus 3 times 1 minus x plus 2y is equal to 3. Now let's do some simplifying. 2x plus y minus 3 plus 9x minus 6y is equal to 3. I'm going to move my minus 3 over to the other side, and I'm going to get 11x minus 5y is equal to 9. And then I'm going to solve for one of the variables. Now, again, it's typical to solve for y in terms of x. So in that case, I would have minus 5y is equal to minus 11x plus 9. And then y is equal to 11 over 5 minus 9 over 5. Got my x. But there's no particular reason why that is required. So feel free to solve for whatever you think would be easiest to work with. 5 dividing by 5 here gives you a nice round decimal number. So if you need to use your calculator, you don't have to worry about repeating decimals. So maybe there's some advantage to that. But when you solve this equation, your dependent variable is now going to become x equals t. That's your parameter. And then y, you're going to substitute your t in for x. So that'll be 11 over 5 t minus 9 over 5. And then you substitute both of these in for z to get your parametric expression for z. So 1 minus 3t plus 2 times 11 over 5t minus 9 over 5, which is going to get me, let's see, 22 over 5t minus 18 over 5. And if I combine my t's, so 3t is going to be 15 over 5. And so that's going to leave me with 22 minus 15 is 7 over 5t, and then 1 minus 18 divided by 5. 1 is 5 over 5, so that's going to leave me with 13 over 5. And so then my vector is going to be t, and 11 over 5t minus 9 over 5 in the y component, and 7 over 5t minus 13 over 5 in the z component. And if I want, I can multiply everything by 5. Again, pointing in the same direction, it's going through the same points. I'm essentially just swapping out the parameter t for 5s. So multiplying everything by 5, I get 5t, and then 11t minus 9, and then 7t minus 13. And so that will be a line that represents the intersection of those planes. It's a vector in 3 space. Now, if I want to write this in symmetric form, remember the idea essentially with symmetric form is to solve all of these components for t and then write them in that form. So if we solve the x equals 5t for t, I'm going to get x over 5 equals t. And then if I solve y equals 11t minus 9 for t, I'm going to end up with y plus 9 divided by 11. And then if I take my z equals 7t minus 13, and I solve that for t, I'm going to get z plus 13 divided by 7 equals t. And then my symmetric equation is just setting these all equal to each other. So x over 5 is equal to y plus 9 over 11, which is equal to z plus 13 divided by 7. So that would be the symmetric form of the same line.